You're welcome, everyone. In this video, we're going to be looking at exercises on indices. We're going to be solving some exercises. And the first exercise here says we should solve 343 raised to the power of 1 over 3 times 0.14 raised to the power of minus 1 times 25 raised to the power of minus 1 over 2. Solution. So we are going to be applying the laws of indices in solving this. Now, when you have a fractional power, as in the case of 343, it's having a power of 1 over 3, which is a fractional power. So from the fraction, the denominator is going to be the root, while the numerator is going to be the power. So if I'm to do this, it's definitely going to be the cube root of 343 everything raised to the power of 1. Don't forget, when you have a fractional power, the denominator becomes the root, while the numerator becomes the power. Multiplied by, so when you have a decimal number under indices, as in this case, and as in the case of 0.14, so it is the best approach is that you convert the decimal to fraction. So converting this decimal to fraction, I'm going to be having 14 over 100, all raised to the power of minus 1. Then I'm going to be having multiplied by, now don't forget, when you have negative power, it means it's going to be reciprocal. That's 1 over. So we are going to be having 1 over, then 25 raised to the power of 1 over 2. Please take note, the negative as the power represents 1 over, and that's why we have 1 over. Then I have 25 raised to the power of 1 over 2. Then we can solve further. So what is the cube root of 343? The cube root of 343 is 7. 7 multiplied by 7, then times another 7 will give us 343. So the cube root of 343 here is 7. So we have 7, then multiplied by, and don't forget, when you have negative power, it means 1 over. So we have 1 over 14 over 100. That's the reciprocal of 14 over 100. And the reciprocal of 14 over 100 is 100 over 14. So let me write it this way. So we'll be having 1 over 14 over 100. So, and it's going to be giving us 100 over 14 in the long run. So we have multiplied by, and we have 1 over. Now you have a fractional power. The power is a fraction, 1 over 2. It means the denominator becomes the base. The denominator becomes the root, while the numerator becomes the power. So it's going to be the square root of 25 raised to the power 1, but I don't need to write that. So which is going to be giving us 7 multiplied by, don't forget, 1 over 14 over 100 becomes 100 over 14. So we have 100 over 14, then multiplied by 1 over, the square root of 25 is 5. And we're going to be simplifying. You know that 7 can go in 7, which is 1, and 7 can also go in 14, which is 2. Also, we know 5 can go in 5, which is 1, and 5 can go in 100, which is 20. And also we have 2 in 2 is 1, and 2 in 20 is 10. So the final answer is 10. As simple as that, applying the laws of indices. So let's move further to the next exercise. If the cube root of 4 raised to the power of 2y equal to 8, find the value of y. So how do we go about the solution? So we have the cube root of 4 raised to the power of 2y. So the first thing we can do is write this as a proper indices. That is, when we have cube root of a number, let's say a, if I want to write it as a proper indices, it's going to become a raised to the power of 1 over 3. Don't forget, when you have a fractional index, so the denominator becomes the root, while numerator becomes the power. So we can also reverse the case. So when you are giving something like this, you can change it back to this. And that's what we are going to be doing. So since we are giving the cube root of 4 raised to the power of 2y, I can change the cube root back to an indices, to indices format. So which is going to be giving me 4 raised to the power of 2y now raised to the power of 1 over 3. So the 1 over 3 is the cube root that you have there. So which is going to become 8. So from here, I can adjust again. So I'll be having 4 raised to the power of, so I'll be having 2y times 1 over 3. Don't forget one of the laws of indices that says when you have a raised to the power of b, then bracket, then raised to the power of c outside, you multiply the powers. So which is going to be giving us a raised to the power of b and c. And that's what we are going to be doing. So it becomes 4 raised to the power of 2y times 1 over 3, which is going to be 2y over 3. So 4 raised to the power of 2y over 3 equal to 8. And as you can see, the bases there, they are not the same, because the base in the left hand side is 4, the base in the right hand side is 8. But if you observe, both 4 and 8, they share the same lowest common base, which is 2. So I'm going to be converting the both of them to their lowest common base, which is 2. So changing 4, we are going to be having 2 raised to the power of 2, because 4 is 2 raised to the power of 2. Then multiplying 2y over 3. So we have multiplying 2y over 3. Then times, I'm going to do the same thing with 8. 2 raised to the power of 3. So having this, so we are going to be having 2 raised to the power of 4y over 3. 2 raised to the power of 4y over 3 equal to 2 raised to the power of 3. So we have 2 raised to the power of 4y over 3 equal to 2 raised to the power of 3. And don't forget, in indices, when we have the same base, we equate the power. So since we are having same base, then we equate the power. So we have 4y over 3 equal to 3, because the base there is 2. Both of them are having the same base. So then we say 4y over 3 equal to 3. So by doing cross multiplication, of course. So we have 4y equal to 9. That's 3 times 3. And dividing both sides by 4. So we have y equal to 9 over 4. And that's the answer. So y equal to 9 over 4. Let's move to the next exercise. Okay, this question here says that we should solve 27 raised to the power of 2x equal to 1 over 9 into bracket 3 raised to the power of x minus 1. Solution. So what we have here, we can actually do this in so many ways. But based on what we have, we can use both 27 and 9. We can use lowest common base. And lowest common base that they both share is 3. So they all share lowest common base of 3. Why? Because 27 can be written as 3 raised to the power of 3. And that's what I'm going to be doing. And also 9 can be written as 3 raised to the power of 2. 9 can be written as 3 raised to the power of 2. And that's what we are going to be looking at here. So 27, I'm going to be writing 27 as 3 raised to the power of 3. Because 3 raised to the power of 3 is 27. Then the 27 is having a power, which is 2x. So I now say raised to the power of 2x. So raised to the power of 2x. So which is going to be equal to, I'll be having 1 over, so instead of me writing 9 directly, I would say 3 raised to the power of 2. So 3 raised to the power of 2, of course. Then multiplied by 3 raised to the power of x minus 1. So I can cross multiply, or I apply the division of indices since they all share the same base. So I can quickly do that, but let me cross multiply. So using cross multiplication, I'll be having 3 raised to the power of 6x. Don't forget, 3 raised to the power of 3 then raised to the power of 2x is going to be giving us 3 raised to the power of 6x. Because when you have a situation like this, a raised to the power of b, then in bracket raised to the power of c, it becomes what? A raised to the power of bc. So you multiply the powers. And that's the same thing I did here. So which is going to be multiplying 3 raised to the power of 2 using cross multiplication. Then everything equal to 3 raised to the power of x minus 1. Of course, since I have 3 raised to the power of 6x multiplying 3 raised to the power of 2, they share the same base and there is multiplication in between them. So the relationship is multiplication. It means I am going to be adding the power. So this is the law. When you have a raised to the power of b multiplying a raised to the power of c, the result becomes a raised to the power of b plus c. So when they are sharing the same base, when they have the same base and there is multiplication, so you add the power. So you add the power. So we're having 3 raised to the power of 6x plus 2 equal to 3 raised to the power of x minus 1. And of course, when we have the same base, we equate the power. So let's quickly do that. We have the same base, then the next thing is we equate the power. So equating the power, we are going to be having 6x plus 2 equal to x minus 1. As you can see, this is just a linear equation which we can easily solve. So we have 6x minus x is equal to minus 1, then minus 2. So we have 5x equal to minus 3. Then divide both sides by 5. X equal to minus 3 over 5. And that's the answer. Minus 3 over 5. Now let's solve another exercise, which is going to be our last exercise in this video. Okay, this question says if 3 raised to the power of 3x minus 8 minus 1 over 3 raised to the power of x minus 2 equal to 0, find the value of x. So we have to find x when 3 raised to the power of 3x minus 8, then minus 1 over 3 raised to the power of x minus 2 equal to 0. Solution. So the best thing I'm going to be doing here is I'm going to be bringing the second term to the right hand side, which is 1 over 3 raised to the power of x minus 2. So we are going to be having 3 raised to the power of 3x minus 8 equal to 1 over 3 raised to the power of x minus 2. And don't forget, from the laws of indices that we have talked about in our other videos. So we have, when we have a raised to the power of minus 1, it's going to be written as 1 over a. So it's going to be written as 1 over, when we have a negative power, it's going to be reciprocal. That's 1 over a. It means when I have 1 over a, I can equally write it as a raised to the power of minus 1. And that's the case here on our right hand side. 1 over can be written as the number you have as the denominator raised to the power of minus 1. And that's what I'm going to be doing. So I'm going to be having 3 raised to the power of 3x minus 8 will now be equal to 3 raised to the power of minus, because of the 1 over. So minus, and what's the power there? X minus 2. So I'm going to put inside bracket x minus 2. So which in turn becomes 3 raised to the power of 3x minus 8 equal to 3 raised to the power of, I can, expand by opening the bracket. We have minus x plus 2. Of course, when you have the same base, we equate the power. So let us equate the power. So equating the power, we have 3x minus 8 will now be equal to minus x plus 2. So collecting like terms, we have 3x plus x equal to 2 plus 8. Of course, 4x equal to 10. So x is equal to 10 over 4. And 10 over 4 is 5 over 2. So x equal to 5 over 2. I believe this is well explanatory. So try to anticipate for my next video, because I'm going to be solving more exercises, complex ones. You are great. Like and share.